Hello, hello. Yes, sounds is all right. Yeah, I'm not lagging. I'm not dropping any frames. It's always good. If anybody is in chat, can you please leave a comment and make sure that you mention whether the font is all right and whether you can hear me all right. All right, I'll start in 1 or 2 minutes. I will do some form of an update or the state of the code base right now, because it kind of changed a little since last time I streamed, and we can then I guess start implementing the new stuff that I wanted to add. If you want to check out the current state of the project, you can go into the commit repo and then pick the REPL feature. This hasn't been merged into master yet. All right, Aziz says sound is not okay. Okay. How about now? Is it okay? And just assume that the sound is all right. All right, I guess I guess the sound is kind of all right, and you can hear me. That's good. So yeah, I started exploring the state of the repo. So last time we didn't have we only had the lexer and the parser part, and we stumbled a little bit on the lexer, on the parser. So the parser state kind of a little bit changed. Now we are able to parse most of the language spec, or at least what we have defined in the G4 file. What has been added was this REPL folder and this eval folder. And this is all of the evaluator code is gonna go in here, and all of the REPL kind of bootstrapping logic is gonna go in here. I added a couple of sample files to kind of make sure that whatever we changed actually works. And we have a standard folder now to kind of put the standard types and the standard built-in functions. So the REPL for now, which is this file, let me demo it for a change. I don't think I can zoom in, can't I? Let me bump up the font, the terminal font. color scheme, I guess. Color scheme, console, debugger. What the hell is? Oh, there it is. So let's bump it to 18. Yeah, I guess now it's better. So the current state of the project is we can run the current main file, and then this will boot us into the Comet REPL. And the Comet REPL, you can use it as any other REPL, like start off by, like, say variable a equals 10. This will evaluate into a nope statement, which is like nothing because it's a statement. We can reevaluate a. We can define functions. Let's say function add, and then it will take two parameters, r and c, and then it will return r plus c. This will add the add function definition. We can then like call in functions, and this will return 3. We can add a bunch of logic operators. Let's say if true, return 1, else return 2. And when we call logic operator, this should return 1 because we expected something to be true. And we have a bunch of commands here, like call in scope maybe, that will investigate the global scope, like function definitions and global variables. Yeah, so it's, we can say that this is like a standard REPL kind of thing. So yeah, we can hit exit and get out. So the REPL in itself, like, it just keeps reading standard input, which is the reader in this case, and then creates one evaluator and use it throughout the whole interactive session. And this evaluator will use it when parsing each line to a root node, and then evaluating this root node and printing errors if any. All right. Now, as we saw during the last stream, the parser has one method that is like public or important, which is the parse method. And this will take whatever's input that it's taken from the lexer and then try to parse it into a bunch of statements and then return a root node containing all the statements. The REPL, the evaluator kind of takes as input the output of that file. So the evaluator has one eval node, and then this one will take a parser node, no matter what the parser node is. And in our case, we know that we're gonna feed it a root node. So to evaluate it for now, we're gonna do a huge switch case statement and then try to determine the kind of the current node and then evaluate the node appropriately. Since Comet is not a statically typed language, no type checker has been added, but we wanted to have the ability to have types. So we kind of defined some standard types that you might expect to find in a language, such as int and bool and strings and functions. This list is not by any means fixed, so it can grow and shrink, but that's gonna depend. I also added one interface to determine what's a Comet object, and we need to know, like, for each Comet object, what's the type and what's a string representation for it. And we have basically like an integer as an object, a boolean, a a string, an error that might be returned, a nope object, which can act as null, but the idea is try to limit the places where we have a null object. We have a function type, and we have a range, and this is used in for loops, so to say. Right. Now the evaluator now just takes in this bunch of this huge switch key statement, and we get the root node, and then we evaluate whatever is root node, and the evaluation is done in the same way we did parsing. So this is like a this is taking like every root node and trying to decompose it into a smaller parts that we know we can interpret, and we do the same like for each composite kind of node. So if we take a look like at the root node example, we know that we will return some kind of comment object, and we will evaluate each statement on its own, and then whatever the return type would be, whatever its value was returned by the latest statement. Every, so to say, prefix expression that has a minus maybe or a bang before would be evaluated accordingly. And then you can see here that we have some type checking. Like we only do type checking when running when the code starts to run. So we don't do any type checking after parsing. So no semantic analysis is done on the code or the syntax tree. Aziz says null equals to nope, true null equals to nope implies false. I didn't quite understand. What do you mean by this? Can you clarify? All right, so same thing is done for binary expressions. So we can evaluate binary expressions such as add, minus, whatever binary expression we define per the language. We do the type checking, and if the type checking matches for some of the cases, we apply it. So whether it's an int, both of them are Boolean, both of them are strings, one of them is a string, both of them have a different type, and the operator is equal or not equal. But other than that, we just default to an error. Yeah, and then for conditionals and control flow operations, we just do as the conditional or the control flow operation kind of expects. So for an if, you just take whatever test that you haven't evaluated, and if you don't evaluate to a Boolean type, you just create an error because you expect that the if part be a Boolean value. Otherwise, if it doesn't, if it is a Boolean type, so we take the predicate and then say if the results a Boolean, since the result is a Boolean, if it's true, we execute the then, otherwise we execute the else. And since we always default the else to an empty block, so we don't need to test actually for the else being empty or not. So whether you declare if and an else, and we don't care about performance, always we have an else as an empty block. So we can always like assume that this exists. Now, let's talk about the things that I want to fix today. So I have a declaration statement, and this is like when calling var a equals something, we evaluate the expression on the right hand side, and if it's an error, we kind of just return it. Otherwise, we have something that is called a scope, which, as the name suggests, kind of maps to a lexical scope, and we say, hey, please store the current identity, or at least bind this symbol, which is the identifier name, like the variable name, to this given value, and then don't do anything, just return an op. And this works fine. And we do the same for like reading when evaluating an identifier. We just take the lookup from the scope and then return if it's not found, if we can't find the given variable in scope, we just return that the value is not founded, otherwise we return the value. All right, so the thing to note about this is so here's my kind of I have a test case in mind that I noticed when it didn't work. So the scope kind of structure is just a bunch of variables that is indexed by name, and every scope by default has a parent, and we need to keep this kind of hierarchical structure to kind of be able to look up values that we don't have. Like if I don't declare a variable A in the current scope, that doesn't mean that it hasn't been declared in the parent scope. And whenever we try to create a new scope, we need to create it from a parent scope. And we do this so that the lookup is kind of linear. So we start at the base scope, and then we go up a level until we can't find the parent scope, and then we declare that the variable isn't found. So this is one solution. Another solution, which is not so much of like we don't care about performance, but not to the point that we have to kind of copy the variables over at each time we create a lexical scope. And we chose kind of this implementation so we don't have to copy the variables from the outer scope into the inner scope. So the thing that I have in mind today that I want to fix is I want to create the scope per block. I want to allow block declarations such as in C or Java. So we need to be able to kind of say this is a block on its own, and it can stand on its own, because we only expect blocks like after fors, ifs, or functions, but we never expect them on their own. And we need to bind the scope per block. So this is one of the things that I wanted to work on. And like I guess I have tests for the evaluator, and the tests are pretty standard. The things that I did before for testing the parser, I'm doing something similar here. But this time I have an assert function instead of having like just a static value. So for each test, there is a source file or a source kind of source, and then an assert function, which is the thing that will take the evaluator and then take the resulting value. All right. All right. If you have any questions, please drop them in chat. All right, so here is a test for string declarations. I have for loops, I guess. Function calls. I don't think I have a test for loops, but this is the test case that I had in mind. May I go? And if I do this, like for so this is the syntax that I kind of used for for. So for I in 0, 2, print ln I. This should work or not. No parsing function found for for I in 0, 2 works nicer if you can remember the syntax. So this kind of returns nothing, which is a nope, and it kind of goes through the numbers from 0 to 2 included, as you'd expect. But if we had like a variable declaration, say, which is global, a equals 1, and we do for I in 0, 2, print ln, we do for j, or for a in 0, 2, print ln a times I, and if we inspect the current scope, we'd find that there is a, and a is equal to 1, and this kind of works. Yes, I'm having a hard time to actually figure out the exact test case. I'm pretty sure something that didn't work for me. All right. So let's see. We expect that the global scope kind of contains one value, which is the current integer, and we expect that the current scope contains doesn't change the actual value, which is like 1. Yeah. So I remember. So now let's keep a as 1, and let's do the same value in 0, 2. And this time let's declare, let's write to it. Let's say a equals I, let's say. If we print a, this will still work, but if we do for I, for a in no, that's not what I wanted. I remember being like the writes having problems. Yeah, I'll get to it. Don't worry about it. For I, let's declare a global variable 10, and then for I in range, or in range 3, or j in in 3, a plus equals I times j, let's say. Say we want to do some math. A equals I plus I times j. And then if we print I is unchanged. So the writes didn't go through for I, because the a variable writes were only bounded to this lexical scope. So what happened, or at least what I think happened, is the value got copied over from started out at 10, and we did the write here for the store. The store has like only applied to this current scope. So there's where the problem lies. So to remedy this, we need that the write be kind of recursive, I guess. So what I have in mind is like, I want to have a test for this to make sure that this doesn't happen another time. So let's say test evaluator, eval, and then evaluating for statement. I want to copy a little bit of this. And let us, yeah, so that's more than I wanted. All right, so let's try to replicate this test case. So we had a 4, right? Yes. So we had a we did a declaration which was a 10, and then we went ahead and started for I in 0, 10, and then we did for j in 0, 10, and we did I equals I plus I times 10, I times j. Now, what we wanted to actually happen is the expected behavior here is we want to find a in scope, and we want it to be an int type. Let's do a, remove this, and we want this to be equal to 10 plus, oh, this is too much. Let's do just 2. Oh, this is what this will yield 10 plus, I guess, 0, which is 1 plus 2 plus 2 plus 4. I guess this is the expected value, which is 9. We expect this to be 19 on it, but if we run this, yeah, we will find that the actual value is 10, and this is not what we want. So now that we have a test, we can kind of try and look at the current implementation of the scope. So the scope has two methods, has a lookup and a store. So we can see that the lookup kind of works the way you expected. So it finds the variable name, and if it finds it, so it starts out from the bottom, and then it goes up, and it stops at the first time it finds it, at the first level, or at the first scope level. So if it finds it, cool, we return it. Otherwise, we just delegate to the parent. But the store doesn't perform this way. So what we want is probably the store should be performing this way. Like, we should be able to kind of store we try to like either we try to store it first and then return the value, and if it's not stored, we store it locally. But this can propagate in a very bad way. So we know that we are only storing something that already exists. So let's say we change this implementation and then say if lookup, see that lookup, I know we want to see like if the current implementation, see that variables, object, and then okay, has the current variable name. So if okay, so if we currently have the variable name, we know that we are the owner of this, and we just do a c.variables of var name equals the new value, which is the object, and then we return true, probably. Now, otherwise, if we don't have, if we are not the owners of it, we delegate the right to the parent. So let's say we want to delegate the right to the parent. So I want to do a c.store maybe, var name and object and parent, and this is only if a c.parent is not null. and we want to return this. And otherwise, if we don't have any, we just return if we don't own it and the parent doesn't own it, we are trying to store a variable that hasn't been declared. Yeah. But this will imply that the scope should actually have a declare method on its own. So we shouldn't be doing the simple store. Yep. So this will probably return std.create error variable something not found. Did you declare it? And the variable name is the warning. And not return it actually, but just yeah, that's kind of tricky. The function will return true. We can add stuff about shadowing in here. True if. Will return true if the assignment of the variable has been done successfully. Returning false. This function implies that the value and should handled appropriately. Appropriately, yeah. And successfully. I never can. I can't write successfully correctly apparently. And I should probably add a function that is called declare. And this will only it will store the current object. So I see that variables of warning equals object, and we'll create the symbol reference in the local scope. All right, so I want to go back to the declaration statement, and so this will imply that we don't have a store now, but we have a declare variable. And in other cases, we would just do the lookup. So, right. We can go back now to the test and see what it does. So it still doesn't work. All right. So this kind of makes me think that we need to debug a little bit more. So let me not try and see where's the for loop. This is the thing. Oh, nope. evaluate for statement, right? So for each one, we have a new scope, and the new scope becomes the current scope. And then we use that scope to evaluate the current body. Ah. All right, so let's debug from here. Should be interesting. Yeah, I'm not interested in this. All right. So we know that the current value of I is 0, right? So we have the first for loop, the second for loop, and let's see the current scope. So the current scope has 0 variables. Huh. Oh, right. So this is a declare, not a store. Because this is the first sound, declare. Declare again. Yeah, on a debug probably. First loop, second loop. Yeah, so the variables are 0 and kind of an empty. And going through to the eval node, we have some kind of node and we have a block statement. We want to evaluate that block. And for that statement, which is the a equals something, which is an assign expression. Right. Yeah. So this will return some form of value, which is the current result, and the result is an integer of 10. And the scope will store, where will it store it? So C, and now we have variables, and variables doesn't contain, right? The parent has I and empty, and the parent has A, right? Now let's see. Okay, not okay, and then do the store. All right. Come back, don't have it. The parent should. All right. And now we should store it. And the current value is, oh, the object. Right. And then we return true, and then we return. So let me kind of, so now I is 0 still. Now I is 1, I is 2. Okay, and J is, there's a comment int of 2. All right, that would be nice to see what gets stored. So we have a block statement. Zachariah, hello. No, you're not. Still debugging some stuff. Thanks for joining. Evaluate statements. We need to evaluate the current for loop, and we have an assign expression, and the result is 12. 12 is, well, so it's 2 times 2. I don't know why is it 12. But it doesn't matter. We need to kind of see what happens when you store. I want to see the current parent variables, and then we have a, and a is mapping to 10 still. Huh. If okay, and we are trying to store object, which is, say what now? Oh, yeah, we are shadowing this declaration. Original value. Oh, that's bad. Yeah, but it still doesn't work. So we start off with this, we go to the, oh, right. Yeah, and I guess even changes should be made to the current scope. Huh, interesting. We have an assign, we have actually just, we have an assign, we have a plus. So we must hit a binary expression if both of them are int types. Go to apply op, then we switch. Let me see what are the intermediate values. Oh, why do I have, oh. Dot dot. Yeah, next time it should be up, and then I wonder why it does stop here. It's another dot dot. Now it's a multiplication between the left and the right value. And the left int is 0, the right int is 0, so that's not gonna be that beneficial. Now it's a plus, 10 plus 0. And yeah, that's still gonna be the same. Now I is 1. Yeah, we should see probably some changes here. So we have 1. So this is the binary expression part. And yeah, apply the current value. Right. So we applied plus, and the plus now is 10 plus 1, which is 1 plus 1, which is good. We just return, and we do the store. All right, so now let's monitor the store. So the variable name is A, the current scope is variables, and parent, which we have A declared in, and A now is 10. So now if we look at the scope, we should have parent, variables, and A should be, oh wait a second, A is not stored. Yeah, A is not stored correctly. I don't know why, but it is not. So what's the current object? Oh, right. We still have the same problem. I just ouch. Yeah. And what do I do with the original value? Yeah, I shouldn't be really caring about it. Yeah, now it passes. Now let us try and run all our tests. I know there's a bug, but I never expected for it to be a shadowing bug. All right, so function declaration. So here, A and then var C equals A, and we wanted A to be found in scope. We did a lookup. Yeah, so we need, for functions, I want to create a kind of a declare as well. I don't want to store in the function declaration kind of stuff, function statement, register function. We don't want to store, but we want to declare. So run tests now, everything runs, and all is green again, which is good. All right. So now I would like to go back to my samples. I have a Fibonacci sample which should still run. So the run may not go. File equal sample fibo.comment, I guess. Is it called fib or fibo? It's fib. That's 89. That's correct. And then func.iterative fib. That's wrong. So iterative, not imperative. Iterative, yes. So we have a result equals 0, var last equals 1, before b last equals 0, before I guess as well, and for I from 2 to n. We do res equals res plus last plus b last, var t equals so we do p last maybe. So p last equals last, and last equals I. And we should return Yes. I don't know if this is correct, but yeah. Cannot find callable symbol, iterative. No. Yeah, this time we found 82. Yeah. Why is that? So I'm missing a 7. Am I losing a value? Last is 2 and P for last is I'm also curious. Is it included? I guess it's not. It's fine. 2, 3, 4, 5, 9, 10. Yeah, 10 is included. Alright. Let's do sample values. Let's do 3. Maybe I'm missing some kind of. Yeah, so now this one prints one more. So the first time we have right, let's see if this sequence is correct. Maybe that's the problem. So we have 2 and then we have 5. And the sequence is 1, 2, I guess 1, 1, 2, 3, 5. And in this case, right, so I probably should why did I have one? So now it's 1 and then 4. I don't know even what I'm trying to do. Fib of 0 is 0. I need to remember the function declaration. Fibonacci sequence. Is it 0 or 1? I don't remember. So it's 1, 2, 3, 5, 8. Yeah. So so 0 is 0. All right. So if n equals 0, return n, return 0, n equals 1, return 1. This can be written as if n is smaller than or equal to 1, just return n, otherwise return that. So the second Fibonacci number. So now I hold the first, and then if I'm correct, it should be something like this, maybe. Right. So Fib of 3 is Fib of 3 is 1, maybe. Yeah, it's 1, and then the next one is 4. I feel like so I have last and before last one, and they both start at 0 and 1, and then the rest is last plus p last, and p4 last now is the last, and the last is res, basically. Yep. If we do now 10, maybe I'll get the same result now. Yeah. That's one stupid mistake though. Alright. So now we have the Fib example running. And cool. Let's make a control doesn't work. Weird. Add fixed scope issue. Okay. Now let us add a couple of things. So I want to add bitwise operators. So logical. So I want to add bitwise, because I guess so arrow shifts will equal something like this. L shift will equal something like or do I have an or before? Alright, or equals like this, and equals this. A good idea would be to add support for semicolons, but I guess this is a PR to be. I'll open it as an issue and then someone can work on it later. So I have an OR and I need a XOR. This and OR and XOR. Do I need something else? Maybe not. So it'd be like good tokens to actually parse. I will also, I guess, parse. Those are not structurals, but I want to parse or and that's about all. Yeah, and I need the semicolon. Yeah, I already do parse it. Great. So let's go to the lexer, and then whenever I find this, if the peak else if l.peak equals this, do an advance and results equals new token. The token type is, for this guy, is right shift or shift, and this is the actual token. I guess something similar to be done in here. Else if l.peak equals this, I'll advance and results equals new token. I'll shift end is, I don't have it, I guess, might as well add it. So case end, so if l.peak equals another end in front of it, so l.advance and results equals new token and else results new token and case again now, or if l.peak equals or l.advance results equals new token, or else results equals new token, or just an or with this. What else? So left shift, right shift, we need probably a XOR. Let me put it on the top. So case results equals no token XOR case results equals no token, not, I guess that covers all of them. Yes, now we need to add a couple of tests. So for control flow, for operators, yeah, I need to add these. So R shift Alt shift. I wanted to also let's add it in here. So we have an end, we have an end, we have an or, we have an or. So we have an and, an or, Um, not sure what happened. We token that closes that. And all right, so we have an end, and then we have an or. And for the last operators, we have an OR and XOR. So and before this. So let's run the tests in here. Not bench, test. All right, so we have support for this now. So let me commit this. I'm missing bitwise header, let's see. All right. Now I wanted to, where's the token? I needed to make some changes to the token section. So any token should have also an associated line number and column number. Line number, which is an int, and a column number. And it starts out with zeros, which means on set, and we can create the same tests for this new token with meta information, and then we'll add maybe line column as ends. All right, now we need to fill in this information. Let's go to the lexer. Yeah, so the lexer should keep two things. The lexer already has a position, so we need only to increment. So the position is the so we only decide columns by whenever we try to escape a space. So let's see, the read number is white space. So this is used in ignore white space, right? We advance, but if l.current equals this, or l.current equals this, maybe on Windows, I guess. I don't know. Golang cross-platform. I guess there's a way to do about this. So println sim. There is another. Maybe I'll add support for Windows someday. But I'm not gonna bother for now. So the L dot line plus equals 1 plus and L dot column equals 0, and we do line equals 0 int and column is an int. Now we need to update every call to new token with so let's see, oh, I need to change in a lot of places. With meta, and we should add L dot line, L dot column. Sweet, works. All right, so let's do the same thing for the come on. What was a shortcut for this? Silly me, I forgot about it. So there is no new token in here. I like column. About reading numbers, whenever we have a new token with meta, L dot line, L dot column. Here as well, L dot line, L dot column. And of course the call is with meta. This, I guess, will help with error reporting in the future. You have a bug somewhere with meta? Yeah. I guess that's the only bug that was in there. Let's run tests again. And yes. Now assert equals won't. Now all of our tests will fail. What's surprising is the column number is always 0. Huh. Alright, so let's do like assert equal t token dot type is get token of I, got tokens I dot type, and we assert that equal just literal is the same as the got tokens I literal. I guess they should ignore the new issues. I want to make sure that test we are running. So, right. So the tokens are 0, which is line number 0, line number 0, column 0. Yep, column number is not updated. All right. And that's expected, I guess, because I never increment the. Whenever we do an advance, we do L dot column plus equals 1. If the position is smaller, yes, otherwise no. And if we advance and yeah, if it's a line break, increment the lines and stop. And lines start at 1. And columns as well, I guess. So let's do that. So line is 1 and column is 1 as well. And column is 1 here. Right. So let's run the test. That should be fine. Oh, there are no breakpoints. Right. So the consume tokens are for the test. I want this is the input. The expected tokens are these, and the got tokens. Right. This these are the columns I read. So this is current line number 1. Column number is 3. It's just correct. Column number is 5. All right. So this is what you'd expect. So I guess that's that. I'm not gonna add tests for this because this is only for error reporting. Commit. All right, now let's commit. I guess we can push this up. I need to log in. I'll just push it later. I'll just put it off stream. We're going to git push. Yeah. Yep. I guess now it's pushed. So let's take a look. I would like to merge this. It's been a while since the last thing that we did. I didn't make sure that the actual test passes. Go test SV. Yeah, everything still passes. Good. So compare, we'll need to create a pull request and I need to log in. All right. Log in, sure. All right, so let's go back to this branch and try to create a PR for this. Compare and pull request to master and sample rebel language. Okay, and then let's create a PR. Hopefully the build is still passing. Okay, so the build is good. But this is gonna take a little bit of a while before it actually get merged. I guess to keep the life short, I'll be stopping streaming for now. I guess I accomplished what I wanted to do by today. And then if no one has any questions, I can end the live now. And then if you want to pull the latest version of the code, you'll find it like merged into GitHub. Right. Nice. See you then in the next one.